Hey, Connor.
Hey,
Since you're here, we'll just go ahead and get started. What questions do you have?
I didn't, so the last page, I didn't really understand it. Like, at all.
Okay, let me see. Let me pull up my version of the assignment. So the last page. Oh, okay. Okay. So one of the things that you'll see in journal articles, and I'm just going to do this on the board behind me, is you'll see what are referred to as box and whisker plots. Well, you saw them actually in the Coot example. So in the case of this assignment, we have birds that are from El Garapatero and birds that are from Academy Bay. And then we have their beak length, right? And so I forget what the averages were, but this is beak length. And so oftentimes the way we display these things is if this is beak length from short to large, the mean of El Garapatero is maybe here, and then they put a whisker on the point that shows you the upper limit of the confidence interval and the lower limit of the confidence interval. And then we put the mean is a dot, and we have the upper limit and the lower limit of that confidence interval. So that's all it is. So it's a confidence interval graph. And let me go to the Coot presentation. So if you go and look at the Coot presentation, why? Come on, PowerPoint. You're slow as the day is long. Here we go. Can you see the Coot presentation?
Yes.
So we didn't talk about this in class, but these are also plots that show not only a measure of central tendency, but also the variation around that measure of central tendency. In this case, the measure of central tendency is the median, the midpoint of a data set, but then it has a box that is the interquartile range. It's the middle 50% of values, and then the top of the whisker up here is the 90% of the data, and down here is 10% of the data. So this is just a way of representing where's the middle of the data, where's the high point of the data, where's the low point of the data. And so we will also, you can also do that by basically just saying, here's the mean, here's the upper limit of the confidence interval, here's the lower limit of the confidence interval. We'll talk today about why it's nice to do this, because if this mean fits inside of this confidence interval, these two means are not different. If this mean fits inside of this confidence interval, those two means are not different. So it's just a useful way of displaying it. So that's it. That help? Okay. Who else has a question?
Shit.
Just jump in whenever you have a question.
On the card trials section of the assignment, that's
Yeah.
Joseph. I didn't know exactly, I have numbers, but I didn't know exactly how to use RStudio to get them. Kind of just did my best, but I got average sample means and a standard deviation, but I don't know if I did it correctly.
Did you send me your assignment?
No, I haven't sent it yet.
Okay.
I haven't sent it yet.
So the trend that you should have seen is that as you got bigger and bigger sample sizes, going from 2 to 5 to 10 to 20 to 30 cards, you should have seen the average converge on the population mean, which is 7. So when
Okay.
I did it, the averages started out around 6.8, which is close to 7, but not as close to 7 as 7.003. And so you should have seen the means get more consistently close to 7 over time, and you should have seen the standard deviations get smaller and smaller.
Okay.
Is that what you saw?
My standard deviations were all around 2.
Oh, even for like a sample size of 30 cards?
Yeah, so I probably did not do that correctly.
Oh, did you just run the script as it was?
I ran the script as it was, and then I entered in different values into a certain part of it and kind of just ran it that way.
Okay. Yeah, so for this script, don't alter anything. So let me go to, let me share. Can you see my RStudio?
No, not yet.
Not yet. Oh, because I stopped sharing my screen. Duh. No, so I have them up already because I was preparing for class this morning. That's weird. Why is it not? I'll just regenerate this. Okay, I may not be asking my computer to do too many things at once. And we're gonna actually go through this question, Joseph, in class, but I'll answer it for you now as well.
Okay, I appreciate it.
Yeah, sure. So I'm gonna just very quickly, I'm gonna just highlight this whole thing and get it to regenerate everything since it wasn't responding a minute ago. So just give me a minute as it populates with all this stuff. And you can run R scripts this way. I don't advise it because it destroys the learning part that is designed into the R scripts, but you can actually run R scripts this way. And now I really am asking R to do a lot of things. My computer did a lot of things. I have like way too much stuff running at the moment. Does somebody have another question while I'm generating this stuff for Joseph?
I do. So
Audrey?
now that I actually understand how to do the graph, if I've already submitted my thing to you, do you want me to just leave it and bring my new graph to class or resubmit it to you?
Like how far off is your original submission?
I did, it was very wrong, but I did like a normal curve type of graph instead.
Oh, I do recall that. So I did look at that. Yeah, don't worry about it, but go ahead and generate a new graph and bring it to class just to get the practice doing it.
Okay.
Remember that this is preparation homework. It's worth 5 points, and a lot of it is about, it's not so much about did you get everything right as much as are you going through the process of trying to work it out. You're gonna make mistakes in the preparatory homework, but it's more graded on completion rather than correctness. And this is it says this in the syllabus also, if you read the syllabus, which you maybe didn't do, but because nobody reads syllabi. Who reads syllabi? So the preparation homework is graded on the basis of, is it evident to us that you made a good faith effort to complete the assignment so that you're ready to go for class? as opposed to practice homework where you're practicing something that we've already been through. In that case, we really are grading on not only did you complete the task, but did you complete it correctly. Does
Okay.
that make sense?
Yes.
So this is why I don't really sweat the preparation homework in terms of my grading of it. I try and ascertain when I grade it, okay, are you making a good faith effort to get the job done? If you make some mistakes along the way, I'll make comments about those mistakes so that you can correct them as you go, but that doesn't necessarily affect your grade on that assignment.
Okay.
Okay. Remind me to explain that to people, because even though we talked about that when we went through the syllabus, I don't know that it registered with most people.
I will. Thank you.
Okay, Joseph, so now I have a bunch of figures generated.
Okay. I ran it too,
Actually-
and it looks pretty similar.
Okay, so actually, let me just do it in the PowerPoint that I have worked up for today, because I realize that I have a bunch of intermediate graphs. So let's do this. So this is basically a preview of what we're going to be doing in class today. So if we take, no, that's the wrong file. Once again, I have way too many things open on my computer right now. Yeah, okay, here we go. So when I ran it, so our graphs are going to look slightly different because these are simulations, and so they're gonna not always look the same. But basically, we begin with the uniform distribution. So, and by a uniform distribution, I mean that we have 4 1s, we have 4 2s, we have 4 3s, we have 4 4s, we have 4 queens, we have 4 jacks. We have the same representation of all the possible numbers. So if you make a jack 11, a queen 12, and a king 13, we have from 1 to 13, and we have an equal number of all of those things. But when you start sampling and calculating the means, can you guys see the 2 card spin samples?
Mm-hmm.
Yeah. We don't get all the representations. So the average should be 7, and this is centered at like 6.8 or something like that. But this is only 2 cards and only 10 samples. If we have 2 cards and 50 samples, we have more things, but it doesn't really start to look like a normal curve. And the average of the sample means was once again only about 6.8, which is 0.2 away from the actual population mean of 7. If we increase to 5, we get closer to the population mean in terms of the mean of the sample means. If we have 1,000 samples of 2 cards, once again, you still see all this spread. But once again, it begins to start to take on more of a normal curve. We increase the number to 5 cards. As we go from 2 cards to 5 cards, look at what happens to the spread of the data on the x-axis. It begins to get narrower. And it's because we have a better idea of the population from 5 cards than we get an idea of the population from only 2 cards. And as we go to 10 cards, it narrows in further. As we get to 20 cards, it narrows in even further. And as we get to 30 cards per sample, it's the narrowest of all of them, which is why I'm surprised that you got standard deviations that are still as high as that, because I think mine went from like a standard deviation of 2 or something like that here to a standard deviation of about 0.8 here. So I'm not sure what happened to you there. It shouldn't have done that. But did your graphs look similar to this? They got smaller and smaller?
I just ran it again, and they did, yes.
Oh, okay. All right. Don't rewrite my
Like
code,
that.
dude. Come on.
I know. First mistake.
Yeah. No, I went to a lot of trouble to make sure that that code ran, so it should have run without any problem, assuming that you just kind of went through it in order.
Yeah, that's my bad.
Okay. But the other nice thing is it generates the graphs, and so you can see those distributions shrinking up as you get bigger and bigger samples. So you're taking a sample of 30 cards from a population of 52 in theory. And so that tells you quite a lot about that population, which is why these confidence intervals are much narrower, because you have a lot more confidence in what the population mean is, for example. Does that make sense?
Yeah, that makes sense.
Okay, good. All right.
Thank you.
Other questions? I am here for you. If you have questions, I will answer them. If you don't, we can all go do other things.
I had a question.
Yeah, Daniel.
So, either I missed it or I misinterpreted the question about the cards, but I completely did, like, the graph that you were showing, I completely did that incorrectly, like the frequency and then the mean. Was that
Okay.
supposed to be on our script? Like, was it supposed to be there automatically, or?
Well, when you're doing the cards, you could actually just do them by hand. So
Right.
let me just walk you through the process of doing a frequency histogram. So in this case, let's see. On the x-axis are whatever the values are of your variable. So this is variable. In this case, the variable that you have is the potential averages. And so they could go from, so the values of the cards go from 1 to 13. And because you're drawing 2 cards out at the beginning, all of the values that you have are either going to be a whole number or a half between them. So you actually have 1.5, 2.5, 3.5, 4.5, etc. And so when you were generating those averages, the frequency histogram is just at what frequency do you see each of these possible bins, these possible values. So if you saw 1, 5, so the x-axis is the frequency. And so the frequency is going to be like 1, 2, or 3, because you're only doing 10 trials. And so if you saw 1, 5, it would look like this. If you saw 2 7s, it would look like this. You had a 9.5 that you saw twice, it would look like this. That's 2, 4, 5. And you might have seen a 3 once. You might have seen a 13 once. That's 2, 4, 5, 6, 7. 4.5 once, and 2 twice. That's a frequency histogram. It's a sloppy, ugly looking frequency histogram, but it looks that way because you only have 10 observations, 10 samples that 10 sample means that you're plotting.
Yeah, I see
So,
that now. After the table, it specifies I completely missed that. That's
okay.
my fault.
All right, not a big deal. Now you know how to do it, and that's the whole point of doing this. You learn things that you didn't know before. Yeah. What else? If you knew how to do all this stuff, there would be no point in you being in this class.
Okay, I had a question on how to do the last graph part. It says not create a graph that plots the sample mean values in each population. Is it the same thing as that?
Unfortunately, Joseph had this question and I just erased it to do this. So if you go to the COOT example, the COOT presentation, I'm going to share my screen here for a sec. This sheet here.
Okay.
You see it? And when we
Yeah.
looked at the data, you see that they've plotted the median, the interquartile range, and the 95% or 90% confidence interval here. And so whenever you display data, so in this case, we had the bird, the El Garapatero and Academy Bay were our 2 populations, and we had beak length, presumably from like short beak lengths to long beak lengths. And I don't remember what the numbers are. I'd have to go and look at my own figures. But you can plot the mean of El Garapatero and you can plot the mean of Academy Bay. And then what you want to do is you want to put a whisker on that plot that basically goes out to the upper limit of the confidence interval and goes down to the lower limit of the confidence interval. Same thing here. What is the upper limit of the confidence interval? What is the lower limit of the confidence interval? And so if you have those values, it's pretty easy. You can just hand draw a graph. You don't have to do it in any kind of computer program or anything. You have the numbers in front of you. You just need to make yourself an axis that is evenly divided so that it's to scale, and then plot where the mean of El Grafitero would be, the mean of Academy Bay would be, and then put a boundary on that for the upper and lower limit of the 95% confidence interval. You've seen graphs like this before?
Yeah.
Yeah,
Yeah.
that's what I was asking for.
Okay. Thank you.
Sure. Sometimes these are called box and whisker plots or whisker plots because the whiskers represent the confidence intervals. What else?
Oh, but everybody left. I didn't even realize.
Oh, did everybody leave? Oh yeah, everybody's in. I guess we answered their questions.
All right, thank
So
you.
that's the other thing. Like for things like this, as soon as I've answered whatever questions you have, there's no reason to hang out. You have other things to do, and so do I. Did we get all
That's
your
good.
questions answered?
Yeah, I was just waiting to see if anybody else like had questions that I didn't think of. So
All right, then I guess we're done.
sounds good. See you
All
in
right.
an hour or so.
Yep, whenever it comes around, yeah.